Welcome to Do the Math America. I am Charlene Math Shaman. I work out of New Elementary Mathematics, Syllabus D, Book 1. You can purchase a copy of this textbook from singaporemath.com. If you made a hard copy of the beginning algebra book that I used for lessons 7 through 47, please hang on to that hard copy as I will circle back to that book after I've completed a series of lessons on geometry from this textbook. Today's lesson covers the material found on pages 245 through 254 of this textbook. First, we draw two parallel lines, then draw a line perpendicular to either one of your parallel lines. Is the third line also perpendicular to the other line? I line up a set square to these lines, and I see that indeed both parallel lines are perpendicular to that same line. Activity 2. Now we draw two parallel lines, and then draw a third line parallel to either of the two lines. The question is the third line also parallel to the other line? From the previous activity, we found that two parallel lines are perpendicular to the same line. So in this case, I will verify to see using the set square to see if all three lines are perpendicular to the same line. And I see that indeed that they are perpendicular, therefore all three lines are parallel to each other. In this third activity, we draw two parallel lines, then draw a transversal, that is a line that cuts them both as shown, and then I label the line segments so that I can point out certain features of the angles of this figure. Angles APQ and PQD are called alternate angles. So just to be clear, the slanted line is called the transversal. Angles APQ and PQD are called alternate angles. Angles BPQ and PQC are also alternate angles. And when we use a protractor to measure these angles, we find that when a transversal cuts two parallel lines, the alternate angles are equal. Next, I draw lines AB and CD intersecting at M. And now I will measure angle AMD because I will draw a third line, LF, cutting through line CD at point R so that AMR or AMD equals MRF. And now I just want to check whether or not lines AB and LF are parallel. So again, I use my set square to determine whether both those lines are perpendicular to the same line. And if they are, which indeed they are, then lines AB and LF are parallel to each other. So I will pause a bit in this lesson and share with you my memories of decades ago learning geometry. Right about this point, when the teacher was explaining parallel lines and angles and transversals, I remember feeling quite frustrated and wondering, where are we going with this? Why do I need to understand angles and parallel lines? So I ask you for your forbearance for a little longer. We are setting up for something very interesting, I promised you. Now back to the lesson. So in this figure I've drawn, angles A and angle B are called corresponding angles. Angles B and angle C are called interior angles on the same side of the transversal. Now we are asked to consider whether the following statements are true. If AB is parallel to CD, and those short slanted lines are the symbol for parallel lines, then angle A equals angle B. Is that true? Now, if you recall from lesson 49, where we discussed angle properties related to straight lines, angle A and angle D are vertically opposite angles. And when any two straight lines intersect, the vertically opposite angles are equal. That is, angle A equals angle D. Meanwhile, angles D and angle B are alternate angles. And as we have just discussed, when a transversal cuts two parallel lines, the alternate angles are equal. So through logic, we can deduce that angle A equals angle D because vertically opposite angles are equal, and angle D equals angle B because alternate angles on a transversal are equal. Therefore, angle A equals angle B. The corresponding angles are equal. Furthermore, if AB is parallel to CD, then angle B and angle C, the interior angles, add up to 180 degrees. That is, they are supplementary. Now, why is that the case? From this figure, we can see that angle A and angle C are adjacent angles on a straight line. That is, they are supplementary, which means that angle A plus angle C equals 180 degrees. And since angle A and angle B, the corresponding angles are equal, therefore angles B plus angle C equals 180 degrees. At this point, I would like to introduce you to some glossary words, axiom and postulates. These are fundamental self-evident truths or statements that are accepted as true without proof, serving as the foundation for a system of reasoning or a mathematical theory. Some examples of axiom and postulates. Through any 2 points, there is exactly one line. This is a postulate in geometry. Things which are equal to the same thing are also equal to one another. An axiom. Another glossary word I want you to know about is theorems. These are statements that can be proven to be true using axioms, postulates, and previously proven theorems. Some examples of theorems. The sum of the angles in a triangle is 180 degrees. This is a theorem in geometry. If two lines are parallel, then the corresponding angles are equal. Another theorem that we had just discussed in this lesson. Now we will summarize some of those axioms, postulates, and theorems that we have discussed in this lesson. A line that is perpendicular to one of two parallel lines is also perpendicular to the other. A line that is parallel to one of two parallel lines is also parallel to the other. When a transversal cuts two parallel lines, A, the alternate angles are equal, and we use the abbreviation. B, the corresponding angles are equal. Here I draw some miniature alternate angles and corresponding angles to remind you of what we are talking about. C, the interior angles on the same side of the transversal are supplementary. And here I jot down the abbreviation for corresponding angles and the abbreviation for interior supplementary angles. And here I draw a miniature figure of the interior angles on the same side of the transversal, which are supplementary. The opposite of the above statements is also true. Two lines in a plane are parallel if they are cut by a transversal in such a way that A, the alternate angles are equal, or B, the corresponding angles are equal, or C, the interior angles on the same side of the transversal are supplementary. Please note that when we indicate parallel lines or segments on a figure, we usually make use of arrowheads like these ones. As you work through the problem sets coming up, you can refer to the summary of axioms, postulates, and theorems on page 246. Find the value of x. From the figure, we see that lines 1 and line 2 are parallel to each other, and line 3 and line 4 are also parallel to each other. So I write that down as a given. Line 1 is parallel to line 2, so then angle 3x and angle A are alternate angles because line 3 is actually a transversal that cuts the two parallel lines, line 1 and line 2. Therefore, angle 3x equals angle A. And I write the abbreviation for that postulate, alternate angles. And in case you find this assertion confusing, I will extend out the parallel lines so you can see how these angle 3x and angle A are indeed alternate angles, because line 1 and line 2 are parallel lines and line 3 is the transversal. Next, we have that it is also given that line 3 and line 4 are parallel based on the double arrows on both those lines. And since line 3 and line 4 are parallel to each other, line 2 would be the transversal that cuts both of those parallel lines. Means that angle A and angle X, the interior angles on the same side of the transversal, and they are supplementary. That is, A plus X equals 180, and I write the abbreviation. Interior angles are supplementary. To support this equation, A plus X equals 180. So from the previous equation, we see that 3x equals A, so we can substitute 3x for A in A plus x equals 180, which gives us 3x plus x equals 180. So now we just simplify. 3x plus x equals 4x equals 180. Now we divide both sides of the equation with 4, and the 4's cancel on the left-hand side to give x by itself, and on the right-hand side of the equation we have 180 divided by 4, and I do that calculation on the side. 180 divided by 4 equals 45. So x equals 45 degrees, and I box that my answer. On this figure, I need to find the angle marked x. Once again, it is given that line 1 and line 2 are parallel to each other because they both have that arrow notation. And to solve this problem, I will now draw a third line that is parallel to both line 1 and line 2 by cutting angle x at the vertex, and I will label that as line 3. And my rationale for doing so is the axiom or postulate that a line that is parallel to one of two parallel lines is also parallel to the other. So line 3 is parallel to both line 1 and line 2. And I justify this statement with its postulate. And now I will use a straight edge to extend line 3 and line 1 out a little farther so that you can see they are parallel lines that have been cut through with a transversal. I will also extend out line 2 with my straight edge to show that lines 3 and line 2 are also parallel lines that have been cut with a transversal. And now I will rename angle X, which has been cut by line 3, as angle A and angle B as shown. So angle X equals angle A plus angle B, or X equals A plus B. And from the figure, we see that angle A is a corresponding angle to the angle below line 2, which is 63 degrees. And since corresponding angles are equal, angle A is 63 degrees. So A equals 63. And I write the abbreviation for corresponding angles as the theorem to support this statement. A equals 63. Next, I note that the two parallel lines, line 1 and line 3, have interior angles, which are angle B and the angle that is 120 degrees. And interior angles are supplementary, so B plus 120 equals 180. And I will extend out the transversal so that you can see that indeed B plus 120 are interior angles. And I write the abbreviation for that theorem as interior angles. Now I can solve for B. So B plus 120 equals 180. I subtract 120 from both sides of the equation. So on the left-hand side, I have B by itself, and on the right-hand side, I have 180 minus 120, which equals 60. So B equals 60. And now I go back to the equation above, X equals A plus B, and I substitute 63 for A and 60 for B, which gives me X equals 63 plus 60. I do that calculation on the side. 63 plus 60 equals 123. So X equals 123 degrees. And I box my answer. Another figure, find the angle marked X. So we study the figure. We see that there are two sets of parallel lines and transversals. So I've redrawn this figure, making the vertex a little sharper. When you draw these figures, they can be approximate, but you should make them large enough and clear enough that you can see the features of the figure so that it will be easier for you to solve the problem. But now I draw another line that is parallel to line 1 and line 2 in such a way that it cuts the vertex. I extend that line beyond the vertex and extend lines 1 and line 2 in the same direction. That will help me visualize the features of this figure, such as vertically opposite angles, alternate angles, or corresponding angles, so that I can use the features of the angles on the parallel lines and any other available information, along with logic and deductive reasoning, to solve for angle X. So now I have set up the parallel lines along with the transversals, so that now I am ready to start solving the problem. So I make note that it is given, based on the arrows on the lines, that line 1 is parallel to line 2, because they both have 2 arrows on their lines. Next, I make note that line 3, which I have drawn, is parallel to both line 1 and line 2, because of the postulate that a line that is parallel to one of 2 parallel lines is also parallel to the other. And in parenthesis, I write the shorthand form of that axiom. Next, I note that line 3 cuts the vertex into 2 angles that add up to 135, and I will name those angles angle A and angle B. So I write A plus B equals 135. And from the figure, I see that angle A is a corresponding angle to the angle above line 1, which is 75 degrees. So angle A is also 75 degrees. And I write the shorthand of that theorem in parenthesis to support that A equals 75. And we use this to substitute 75 for A in the equation above. A plus B equals 135, and we substitute 75 for A, so we have 75 plus B equals 135. We subtract both sides of the equation with 75. On the left-hand side of the equation, 75 minus 75 cancel, leaving B by itself. On the right-hand side of the equation, 135 minus 75, I do that equation on the side, leaving me with B equals 60. So I go back to my figure and label angle B equals 60, and I make note that angle X has a corresponding angle. This angle is the interior angle on the same side of the transversal, and it is supplementary with angle B, which is 60. I will label this corresponding angle angle C. Angle C equals X because corresponding angles are equal, according to the theorem, which I write in shorthand next to the statement C equals X. And as I made note of earlier, angle C and angle B, which is 60 degrees, are supplementary, which means B plus C equals 180 degrees. And I write that theorem in shorthand. Interior angles are supplementary to support B plus C equals 180. So now I can solve for C because B equals 60, so I substitute 60 for B, and I substitute X for C because C equals X from above. Subtract both sides of the equation with 60, which leaves X equals 180 minus 60. I do that equation on the side. 180 minus 60 equals 120. So X equals 120 degrees. I box my answer. The problem sets for this lesson are on pages 248 to 252 of the New Elementary Mathematics book. I suggest you do every problem in this problem set to get a good handle on how to solve these kinds of geometry problems. I would expect that it could take you several days of effort to solve each of these problems, because realistically it takes time to sit down and study each problem before you can come up with a strategy for approaching it. And please check your answers with the solutions in the back of the book to make sure you did the problems correctly. I also ask you to look at the chapter review on pages 252 to 254, which summarizes these principles that we've discussed the past few video lessons. I hope you found this video helpful. Thank you for joining me at Do the Math America.